geometric sequences. So we've done arithmetic sequences and arithmetic series, so now it's time for geometric. So write the next two terms. 4, negative 20, positive 100, negative 500. And then, so what's the rule? Sorry? Yeah, so we are switching from positive to negative, but more specific, how do we do, what's the number? Times negative 5, right? Oh, yeah, 12,500. All fixed. Note, so what's negative 20 divided by 4? Negative 5. What's 100 divided by negative 20? What's negative 500 divided by 100? Okay, so what we have is, and we're pretty good at looking at the pattern, right? So by just looking at it, we say, well, yeah, it looks like you're multiplying by negative 5, right? 20 thirds, 10 thirds, 5 thirds, 5 sixths, 5 twelfths, and 5 24ths. So what's the rule? Divide by 2? Yeah. I'm going to go with multiply by a half, just because I think it's easier. Right? So I multiply this by a half, the 2 cancels into this, give me the 10. Multiply this by a half. Now at this point, this becomes odd, right? So you can say, well, divide by 2, but I think when we're dealing with fractions, instead of dividing by, I don't like fraction divided by something, right? So multiply. A sequence is geometric if the ratio, okay, so take a term divided by the preceding term between consecutive terms is a constant. Yeah, constant. This, if you're ever in doubt, read ahead. This constant is called the, so in arithmetic it was the common difference. So here it's the common ratio. And is denoted by what letter could we possibly use for ratio? R, right, which fits in with September 19th, which is International Catholic Pirate Day. It's actually a thing. So, note that R is equal to T2 divided by T1 or T3 divided by T2. In other words, take any term T sub n and divide it by the preceding term T sub n minus 1. The terms of a geometric sequence can be expressed in terms of T1 and R. Okay, so remember with arithmetic we did, T1 plus D, T1 plus 2D, and so on. Here we do T1, T1R, T1R squared, T1R cubed, and so on. What's T10 going to be? R to the 9th. And what's T sub n going to be? Yeah, so T1 times R to the n minus 1. Right? And remember, order of operations, you're going to have to do the R first, right? You have to do the exponent first, then do the multiply by T1. The general term of a geometric sequence is T sub n is equal to T1 times R to the n minus 1. Right? And we do that so that T1, if you put a 1 in there, it becomes T1 R to the 1 minus 1, which is T1 R to the 0, and anything to the 0 is 1. State the common ratio and the next two terms of the following geometric sequence. So, what's the common ratio? That's kind of not obvious, right? It's not like, hey, multiply by 2, or so how do we figure it out, right? Well, we just take a term and divide it by the preceding term. So what's 150 divided by 180? Well, you cross off the zeros, right? 10, we got 15 over 18. What number goes into 15 and 18? How many times? So you get 5 over 6. 1. ratios should be never express a common ratio as a decimal, right? Like unless it's 0.75 or 0.5, you can get away with that. 5, 6, we can't get away with, right? Because that's a non-terminating, it's a repeating decimal, but it's non-terminating, right? So we are, as a general rule, always going to express ratio as a fraction. Okay. So what's next? Now at this point, they will share no common factors, right? So it's going to be 625 over 6, right? Multiply 125. And then you can check the arithmetic. Now in your calculator, let's do this. Let's video. Okay, so you go 180 times 5 divided by 6, enter, times 5 divided by 6. Wow. Just a bracket there. Okay, that's 5 divided by 6, enters 120. And then you just keep hitting. And then, so this supposedly should be 625 over 6, right? I guess. Yeah, it is, right? And then this would be 3125 divided by 36. 3125 36. Yeah. Okay. So I mean, if you need to generate like 10 terms or something, you don't want to sit there and just keep going times. I think you do it twice, and then every time you hit enter, it's just going to bring it down, and just keep doing it. For the G-max, state the equation for T sub n. So what's the first thing we got to figure out? Well, we know T1, right? T1 is 1600. What's R? Well, it's 1200 over 1600, which is 12 over 16. They're both divisible by 4, giving us 3/4, right? Okay, we got T1, we got R. So T sub n is T1 times R to the n minus 1. T sub n, so in this case, we're not looking for a term, we're looking for an expression for the general term, is 1600 times 3/4 to the n minus 1. Now sometimes what you can do is you can kind of simplify that a bit if you multiply this by 3/4 or by 4/3. If you take this back, like if you say if there were a term before that, what would it be? Actually, I don't think it's a very nice number, so we're not going to do that. No. Okay, determine T6. Sometimes you can get a simpler expression. You could just have an n there. Okay, but in this case, I don't think it's going to work out that way. Okay, so T sub n is T1 times R to the n minus 1. So always start with the formula, right? It gets you a thinking set, right? Because, you know, on the test you're going to be doing arithmetic sequences, you're going to be doing geometric sequences. So by showing the formula, you at least get into the right mode. Okay, I'm doing a geometric sequence. Here's the term. I want T6. I know T1. R is 3/4, and this is 6 minus 1. So this becomes 1600 times 3/4 to the 5th. And then we could just go in here, 1600, bracket 3 divided by 4, bracket to the power of 5. And okay, we don't want that, you know, so we'll just go math. Enter, enter, change it to a fraction. 6075 over 16. determine which term is 49,275 over 4,096. So what are we looking for here? N, looking for N, right? Okay, so formula, T sub N is T1, R to the N minus 1. We know T sub N, it's 492075 over 4096. That's equal to 1600 times 3/4 to the N minus 1. So, what's first step? Divide both sides by 1600, right? Got to get rid of that 1600 up front. Okay, let's get a calculator out. We got 492,075 divided by 4096. I'm just going to hit enter on that, and then we'll divide that by 1600. 0.075. Okay, but what is that math? Really? Give us a fraction. Okay. 492,075 divided by 4096 times 1600. All right, what do we got? 0.075 0846 Okay, how are we going to solve that? All right, think about it. Okay, so 3/4 is 0.75. And 3/4 squared will be like 9 over 16 and that. So there's some power somewhere down the road which should be equal to this, right? Like this assumes that this is a term, right? So given that this is a term in the sequence, it'll be found by just continually multiplying by 3/4, right? So we know that it's 3/4 to some power. So we can solve this graphically. Okay. Or using the table, I guess, really. Or graphically. Okay, so why 1? Well, we'll go 3/4 to the power of x minus 1, right? Because that's what we need. 3/4 to the n minus 1 is equal to this value. And this value, 0.075084686. I kind of wish I could just bring that in somehow. I guess I could have recalculated it. Actually, let's do that. So let's go bracket. This time I'll throw the brackets in. 492,075 bracket divided by 1600. Oops. Insert. Wait. First it was divided by 4096, then divided by 16. Okay, and that should give us that number, right? Now, if we graph this, well, okay, do we have to graph this, or if we just look in the table? So I'm looking for where these are equal. It looks like 10. Yeah, okay. So see at 10, they're the same. Okay, now if you want to see, is this really the number? I think you can arrow over there. 0.07508468627. Okay, well oh, and that is 2, right? So they are identical here. This just rounded because of the display in the calculator, and this is just showing you more digits. Okay, so they are the same. Okay, so oops, jumping ahead. So n is equal to 10. N is equal to 10, and so this is the 10th term. I'm just surprised the calculator wouldn't give us 10. Let's just see. So let's quit out of that. So if we went 1600 times 3/4 to the n minus 1 will be to the power of 9, right? There's that. 1600. Oh, right, which I guess is that. Now will it convert it to a fraction? There we go. 492075 over 409. So I don't know why I wouldn't do that in the first place. Huh? Yeah. But I mean, I tried to divide it by 1600 and convert it to a fraction. Maybe, let's try this. 49207.5 divided by 4096. Is that two fractions? Times 1 divided by 1600. Okay, won't do it. Yeah, it could be student rounding where I get so too many decimal places, can't do that. So, okay, sometimes you can't do that, right? But you could do that, and maybe not entering this into y2, but instead putting in the expression so that it would be exact, helped us out, right? We still would have got 10. It still would have been to the 4 decimals that we could have seen. It would have been the only solution, but. Yeah, so instead of entering this into y2, enter this, divided by 1600. There is a way to solve this using algebra, but you won't learn that until next year, right? There's a way to solve for that unknown exponent. Anyways, in a geometric sequence, T1 is 12 and T6 is 91.125. Determine the common ratio. Okay, so we're given T1 and T6, and we have to figure out R. So here's the way we do this. T6 is equal to T1 R to the 5th, right? It's R to the n minus 1. And we know T1. So 91.125 is equal to 12 R to the 5th. 5 both sides by 12. So how do we get R? How do we un-fifth power it? We fifth root it. How do you do the fifth root on the calculator? I just do it to the power of 1/5. You can do fifth root, right? You do have the root key there, but I prefer to do this. Easier, I think. Easier for me. Okay, so let's clear this. So what do we got? 91.125 divided by 12 to the power of 1 divided by 5. 1.5. 3 halves. Right? 3 over 2. So equals R. There's your common ratio. Right? You can also do fifth root. So I think it's but to do fifth root, you got to put the 5 in first, then go to the math menu, number 5, which gives you the x root, and then put in the 91.125 divided by 12, and get the 1.5. Okay? Either way. Questions so far? Insert 3 geometric means between 6 and 96. 1, 2, 3, and 96. So this is a very minor extension of what we just did, right? We got T1. This is T2. This is T3. This is T4. This is T5. We know that T5, well, general formula, T sub n is T1, R to the n minus 1. T5 is T1, R to the 5 minus 1, or R to the 4th. T5 is 96, so 96 is 6, R to the 4th, divide by 6. 16 is R to the 4th. Now think very carefully before you answer. What's R? Is that all? Plus or minus 2. It's an even power. So r is plus or minus 2. So the numbers, if it's 2, then we get 12, 24, 48, and 96. If it's negative 2, we get negative 12, positive 24, negative 48, and positive 96. Right? So if you think, I mean, the last question didn't ask us to, right? But it said determine the common ratio. If we had to do the terms, see, it's r to the fifth. A fifth root of a positive is positive. The fifth root of a negative is negative, right? So if this is an odd power, then there's only one possible sequence, right? But if it's an even power, in which case we're generating an odd number of terms, then we can start flipping terms, right? We can go from positive to negative to positive to negative, and we'll be back up to positive when we get to this term. Okay, and the other one, if there was another blank there, we wouldn't be able to flip, right? If this was positive and it was out here, the only possible ratio, because you would have had an odd power here, would be either positive or negative, right? You can't change it around. Okay, so watch out. When you've got an even power, you'll be able to generate two sequences, right? In a geometric field, we got T5 and T8. Determine the values of T1 and R and state the values of the first three terms. So we need T1, we need R, we need T1, T2, T3. But what we really need is R, right? Okay, so here's what we can do. I'm going to show you the more formal way, and then we'll kind of talk about an informal, like, hey, how would I do this if it was multiple choice? Right? Like, they're just asking what's R. But we can do this algebraically. All right, so we start off, we've got the formula. We know that T8, which is equal to negative 1458, is equal to T1R to the 7th. Right? And we know that T5, which is equal to 54, which tells us that the R has to be negative, right? Because the only way you're going to get from a positive term and then have a negative later is to have a negative R. That's T1 R to the what? 4. So what we're going to do to solve this is take this, and it's kind of like a system, but the way we solve this is we're going to divide this and divide this. So what's negative 1458 divided by 54? It's got to be negative 27, right? It's the only possible answer. But work it out, is it? Yeah, okay. It's negative 27. What's T1R to the 7th divided by T1R to the 4th? R cubed. R cubed is negative 27. What's R? Negative 3. Right? That's the only possibility, right? There's no plus or minus 3 because it's a cube, right? It's R cubed. If a cubed is negative, then the cube root is negative. If a cubed is positive, the cube root is positive. Okay, we got R. Now we got to get T1. So we know that 51 is equal to T1 times 3 to the 4th. 54, right? Work out a bit easier. What's 3 to the 4th? Oh, right. What's negative 3 to the 4th? Yep. Yeah, but it should be negative 3. The answer will work out the same. 81. And what's 54 divided by 81? 9 goes into that, right? Oh, wait, but 2 over 3? Yeah, so they're both divisible by 27, right? So T1 is 2/3. All right, so now we can generate the sequence. So T1 is 2/3. T2 is 2/3 times negative 3, which is negative 2. And T3 is 2/3 times negative 3 squared, right? Or you can just multiply this by 2/3, right? But, which is 2/3 times 9, which is 6. Then after that, the number is just, there's no more fractions, right? After T1, there's no more fractions. You're just multiplying by -3. So, which is the easier way to get that, right? So 2/3, -2, +6, -18, +54. Hey, wait, that's right. So 2/3, -2, +6, -18, +54. So our fifth term. Keep going, and in 3 more terms. Okay, so how would you do this if it's a multiple choice question? You just say, okay, I got T5, I got to go to T6, to T7, to T8, right? I'm going to have to multiply by R 3 times, by R, which is R cubed. So R cubed is going to be the ratio of this, right? So I just take that, divide by that, take its cube root. Okay, so if you're doing it algebraically, right, determine, this is what you're going to show. Okay, I got this. I'm going to take this divided by this. That gives me my R cubed. If you're not doing it algebraically, you just do this, cube root it, and you're there. Okay, question? Nope. Sweet. Let me know what it is. What's the last example?
I think it's
8. Okay, keep going. 3 consecutive terms. Oh, I like these kind of questions. 3 consecutive terms of a geometric sequence are x minus 7, x plus 9, 4x plus 12. Determine the value or values of x. So how do we do this? Here's what we do, right? We know what the common ratio is. So what's an expression for the common ratio? X plus 9 over x minus 7. What's an expression for the common ratio? 4x plus 12 over... What are we going to do with these two things? We're going to set them equal to each other, right? They're both R. So this is what we do, right? We say, okay, look, I know the common ratio is x plus 9 over x minus 7. But I also know it's 4x plus 12 over x plus 9. So let's set those two things equal to each other. And then I'm just going to cross multiply, right? We're going to multiply both sides by the lowest common denominator, or cross multiply. So it's just x plus 9 times x plus 9 is equal to 4x plus 12 times x minus 7. In this case, you add the brackets. On the test where you shouldn't have added the brackets, don't add the brackets, right? Like it was what it was. But here we're multiplying. So, do it, multiply it out. If you're going to embarrassingly get 2 terms on the left-hand side, you can make that mistake in private. I'm going to change it. Okay, so multiplying binomial times binomial, they're not special, right? We're actually squaring a binomial. Not a difference of squares, which is the only way you get 2 terms. Okay, so it's x squared plus 9x plus 9x plus 81, or x squared plus 18x. And this guy is 4x squared. Minus 28 plus 12 is minus 16x minus 84. Okay, how are we going to solve that? Yeah, so get it all on one side, right? And then solve. So what we're going to do is subtract, so we'll get 3x squared minus 34x minus 165 is equal to 0. This just has to factor, right? It's got to factor. Well, so if it factors, there's a 3x and an x. I need 2 numbers to multiply to 165, and they're going to give me a 34. That'll work. So negative 15 and 11. 3x squared minus 45 plus 11 is mine. Okay. Yeah, so you're thinking, I could never do that, right? Like, I couldn't look at that and just factor it. But so here's a couple of things. Number one, it's likely that x is an integer, right? Or more than one, or fractions in this case, but you know, nice-ish numbers. And so what you could do is take b squared minus 4ac, which is the discriminant, right, but is also the thing, and then take its square root, and that'll sort of help you to figure out what the roots are likely going to be, and you can work back to the factors. So x is negative 11 thirds, or x is 15. Okay, so two possible values. I'll work out the 15 one, right? If it's 15, we get 8, and then we get 24, and then we get 72, right? We say, hey, 15, that gives me a geometric sequence, gives me 8, 24, 72, the common ratio is 3, the first term is 8. If it's negative 11 thirds, then I get, I don't know, so, you know, well, if it's negative 11 thirds, what do we get? We get negative 11 thirds minus would be negative 32 thirds. Negative 11 thirds plus 27 thirds will be 18 thirds. And this will give me negative 43 thirds plus 36, negative 7 thirds. And if you want to figure out the common ratio, you're going to take a term, 18 over 3 divided by negative 32 over 3, which is 18 over 3 times negative 3 over 32. Negative 18 over 32, or negative 9 over 16. I guess negative 9 over 16. And if you took this and multiplied it by negative 9 over 16, I posit you'll get that. Okay. Nobody asked you, and you don't have to test that out, right? Okay. But if you wanted to, that's what you would do. Okay. You would not do that in the middle of the test, right? I mean, at the end of the test, you got some time. At the end of the test, you go back and say, all right, let's figure this out, right? What is it? Okay. And then the way I would do that, really, is just to, it's like, I think the number is negative 11 thirds, right? Negative 11 divided by 3. And I'm going to store that in A. Okay. And then I'm going to take that number minus 7. Get a fraction. There's my negative 32 over 3, right? And then I would take that number and add 9. And with that to a fraction, right? Get my 16 over 3. If you can do math. That makes it much nicer then, right? 16 is like negative a half. Nice if you could do arithmetic. Which means that that one's blown too then. 4a plus 12. Nice of you to correct me, thank you. This is all your fault. Thinking I could do arithmetic. All right, that actually looks like it, right? Because negative 32 to 16 to negative 8. Ah, okay. That's a bit more obvious than this negative 9 16 stuff. That's why we use calculators. A new car that costs $36,000 depreciates by 15% of its current value each year. Determine the value of the car after 6 years. Okay, T1 is 36,000. What's R? The whole key to the question. What's R? .85. Why 85? Why not 15? Yeah, so for those of you who couldn't hear, I'll repeat that. If you go down by 15%, then you're worth 85% of what you were worth. Okay, so in this case, the common ratio is it's 100% minus 15%, 85%, which is 0.85. Right, common ratio always has to be a decimal. Well, you can use 85 over 100, and in this case, we get to use the decimal, right? So I'm going to yeah, go ahead. You can use the decimal here. You can use 0.85. Okay, we don't need to do a fraction. Determine the value of the car after 6 years. So we got n is 6. T sub n is T1, r to the n minus 1. T6 is 36,000 times 0.85 to the 5. And what's that work out to? 36.85 to the 5. 15,973.39. It's dollars, so round it to 2, unless it says to the nearest dollar, then it'll be 15,973. Okay? So, big thing here is depreciating by 15% means that it retains 85%, right? You're not going to multiply. If you take 36,000 multiplied by 0.15 to the 5, you've depreciated it by 85% each year. Okay, so just a point to keep in mind. Do a few examples like that. Okay, ready? Last one. A photocopier will only enlarge an image by 10%. Determine the number of enlargements it will take for an image to be over twice the original size. Really? That's grammatically messed up. To be turned over twice its. Yeah, either it's the original size or the original size. I don't know. It doesn't really matter. Whatever you like. All right. What's the original size? 1 or 100%, right? What's it going to be when it's over twice its original size, or at least twice its original size? 2 or 200%. Okay, so let's say we go from 1 to 2. So we're going to say original size is 1 over twice. So we're going to work out how long does it take to be 2, right? Or how many. So we want to know how many enlargements to get to 2. Right. We work this out, we're actually going to get a decimal number for the number of enlargements, right? And then we'll just go one bigger than that, right? We'll just, well, if we went one smaller, we wouldn't be quite at 2, and we want to be at least. So it says over twice its original size. So T sub n is 2, and T1 is 1, and R is what? 1.1, right? So if you're increasing by 10%, then your new, right, it's not 0.1. If it was 0.1, then we'd be cutting it by 1/10, right? So it's 1.1. So if you're learning big, this is a big lesson on depreciation and appreciation. This is appreciating or getting larger, right? It's what you want your money to do to grow by an amount. So if you figure I go to the store and I want to buy something, you can multiply by 1.05 to figure out how much is it with tax, right? So the 5% is, you know, what the price is going to grow by. And so you're paying 1.05. You're paying 105% of whatever is listed, right? Unless it's groceries or something, then it's tax exempt. All of that, right? So R is 1.1, and what we want to get is n. Okay, formula. T sub n is T1, R to the n minus 1. 2 is equal to 1 times 1.1 to the n minus 1. Divide both sides by 1. Like that's needed, I guess. 1.1. And solve this using the calculator. So just clear this out. Clear this. This will be a 2. This will be 1.1 to the, and I'm going to go x minus 1. Right. That way we're going to solve directly for n. Okay. So we can go into the table really again. And we're saying, okay, so look at 8, it's 1.9487. And at 9, it's just a little over 2. So how many enlargements? 9. So n is 9. Using calculator, n is 9. So we need 9 enlargements. So it takes 9 enlargements to be over twice its original size. Or to be over twice the original size. Okay, and next year you'll learn how to solve this using not the calculator. That's not entirely true. You'll actually use the calculator, but differently. You won't have to do it graphically. That's it, right?
Yeah, that's it.
Cool. Okay.